So we are doing Cloud Security Chaos Part 2. I know that if you've seen any of these talks before, it's sort of a series of talks we've been doing in cloud security in the finance industry across the board as we've gotten through a bunch of different organizations. So it's really a consolidation of 30 or 40 organizations that we've worked through and the sort of security experiences we've seen through that. So I think the first thing is, one, it's a completely Simpsons theme. So come for the gifs and the memes and stay for the content, and we will hopefully entertain you if nothing else. So I guess the next thing is why listen to us? Who are we? So I'll turn it over to Mike first.
Yeah, so hi, I'm Mike McCabe. So I run a security consulting company that focuses on application and cloud security. So I've been fortunate enough to work with some really interesting clients who are going through kind of cloud migrations, cloud journeys, either on-prem to cloud or just maturing their cloud program overall. So this talk is kind of distilling a lot of what I've learned working with those different clients, some lessons learned and some trends and things that have worked and things that haven't worked in one talk.
And I'm Ken Toller, and I've been in the industry for about a decade or so, and I've been back and forth between consulting, and I spent 4 years running a security team in a small fintech, about 200 to 700 employees. And so this was my life most of the time, just taking a lot of punches, trying to figure out how to make things work and do this systematically and in operations. But recently, I switched back to consulting, so now I get to watch from the outside and do all this again and try to bring some of that experience to bear for these teams. So I'm working a lot in DevSecOps, cloud security, blockchain security, and so and now I'm back in the consulting game and trying to change the landscape. So we started this whole series about not 5 years ago. It seems like 5 years ago. So 2 years ago, with 3 finance companies, but recently we've added another, so we've gotten up to 4. And that 4th one is introducing sort of blockchain into this finance with Maggie Smith. So as I said, all Simpsons themed. We got Maggie Smith, which sort of represents your startup, super startup blockchain organization, probably like 1 to 3 people. Bart's Bank is like your startup, 20 people or so, and themes that we are facing there. Lisa's Lending is like your small, medium-sized business, 200 to 700 employees, and kind of how security grows there. And then Homer's Homeowners is your super enterprise organization, thousands of employees, large security programs, enterprise scale. So we'll kick it over to Mike to talk about Homer's Homeowners. That's twice I got that.
Yeah, that's good. I'm not going to try to say it because you guys have already heard it twice. So
to talk about that, start there.
Yeah, so Homer's Homeowners kind of represents, it was built off of some work that I've done with one client that's a very large Fortune 20 company that manages trillions of dollars worth of money, and they have been in the cloud for a long time, a pretty early adopter in the financial world, but it was they've now kind of moved to the point where they're trying to move completely off of on-prem into the cloud. So that's a big jump from just having some stuff in the cloud, some stuff on-prem. So they're pretty mature in the sense of they have a lot of experience doing, using the cloud and having applications run there, but there's still a lot of complexity, both from the fact that it's a huge organization, thousands of applications. They, have some stuff on-prem, some stuff moving to AWS, some stuff moving to Azure. They're also regulated, so that's always kind of a facet of it as well. So they started out, typical AWS user, very simple architectures, EC2, RDS, maybe, some kind of load balancer. Things over time got more and more complex. They moved to more kind of API integrations, a lot more applications, a lot more AWS service use, to where they are now, which is, hundreds or if not thousands of applications, 300 plus AWS accounts, some stuff in Azure. And just crazy, cutting edge work to kind of control all of this chaos. So security along with this organization, trying to keep up with what the organization is doing, trying to support it without kind of hampering things. So security has to keep up with all these new services. Everyone knows that AWS and Azure and GCP, they release new services all the time. So security always has to keep up with kind of supporting what the business wants to use, whether that's container-based stuff or AI, ML, or any other service that the application teams want to use. Also supporting application patterns, so new ways for people to use services, new network patterns. Again, this is when you're managing 300 accounts, you have to find a very strategic way of managing network patterns. And on top of that, dealing with kind of inadequate security tooling to kind of manage all these things. At the same time, security is trying to kind of upskill and learn cloud. So there's a lot of talented AppSec people, there's talented architects who've done application architecture for a long time. But cloud is a very different world from those areas. So I'm not sure if anyone's done hiring in this industry, but I've done a lot of hiring for AppSec folks and CloudSec folks, and I found it incredibly difficult to find good AppSec folks. Now we're in the same spot with cloud security. Just not a lot of people have up-to-date and kind of real in-depth experience with cloud security. So that's kind of the challenges that they're working with. So what is working? They have patterns for how applications are built. That works well. They have an account structure that helps support their network patterns. They have baselines to kind of push those things, make sure that they're, that they're sticking to what is the known good. What's not working for them, kind of a lack of uniform deployments, and what that means is, things get to the cloud in different ways. Some stuff is manually pushed or changed. Some stuff is done through CI/CD. There's not one pipeline for everything. The number of alerts, when you have 300 accounts, you have thousands of apps, you have thousands of, pretty much everything, S3, EC2, RDS, all of that stuff. You're going to see a lot of alerts. And what that leads to is someone working to remediate these issues, working with app teams, services teams, to try to fix these issues. And that process takes a very long time. And you can never scale up to the number of people that you need to remediate all those, and you always are reliant on app teams and infrastructure teams to fix these issues. So that's kind of the areas that they're struggling. So they asked, how do we solve this issue? How do we make things more uniform? How do we inject security at the beginning? And so that's kind of going to the source of your infrastructure. So I'm sure a lot of folks here are familiar with infrastructure as code. If not, it's basically writing out code. It's usually just kind of a descriptive language, not true code. Sometimes it is. And that is used by either something like CloudFormation or Terraform or Azure ARM to deploy infrastructure, but just based on your written code for that infrastructure. Versus kind of going into the AWS console, clicking, give me an EC2, or using the service catalog, something like that. So this removes a lot of manual error-prone work for deployment. You can force code reviews, you can force linting tools, security tools, all those kinds of things on top of this process. And I think it's, the last time we did this talk, I said that I think cloud in general represents a huge opportunity for security, because everything is API driven, everything is, data you can harvest and you can action on, you can fix things immediately in the cloud with kind of the right tool set. And I think infrastructure as code is the next kind of step for that, and that's where security as code comes in. So with security as code, you can write actual code. A lot of folks are familiar with SaaS tools for application security, or even just writing regexes to look for common issues. When we do assessments, using regex for some common issues is pretty something we do pretty regularly. So this is just taking those kind of same SaaS approaches to infrastructure as code. The good thing about this is it can scale to your cloud program. You're not having someone do manual code review on your Terraform, and you don't have to have constant security input because you have automation to handle a lot of that. So some of the common infrastructure automation tools, like I mentioned, CloudFormation for AWS, Azure ARM for Azure, and then Terraform, which is multi-cloud, so you can write Terraform and use it for AWS or Azure or GCP. It's not usually write one file that works across the board, but you can use one tool set to work across the board. So one example of how this infrastructure as code works, I've worked on a project for a long time that's using Terraform Sentinel, which is it's a paid for commercial product from HashiCorp, but it's an infrastructure as code tool where you have your Terraform sitting in BCS, GitHub, whatever. You send it off to do a deployment. So Terraform does a plan. What that represents is what is actually going to be going live, or what you're modifying, or what you're destroying. And then you run these checks, Sentinel checks against that. And those will do all of your security checks, your compliance checks, all those things against what is about to be deployed. If all of those, if all of those are green, you apply it, and then you have infrastructure. So some of the benefits, you write this once, you write all your security policies once, and they run against any Terraform, any CloudFormation, whatever you're doing. You're not having to constantly rewrite a different tool for a different scenario. They're pretty high fidelity. I mean, I'm used to using SaaS tools that give you a lot of false positives. These kind of rules that you write are generally pretty high quality because you're writing them customized to your environment and your application. And so they're highly customizable. You can make them as unique as you need to be. We write ones that have unique regexes for exactly what someone is looking for in a naming standard, for instance. You can make them very customizable. You can build in exception processes into them, which is really helpful if you have, not everyone can always follow all the rules, so you can build that in, and they're very fast. We have, one of the projects I've worked on has 300 plus rules, and it runs, I think, in 10 to 30 seconds at most. So this isn't something like a SaaS tool that's going to block your developers from deploying infrastructure for hours. So what does this actually look like? So this is an example of HashiCorp Sentinel. So this is just blocking kind of what EC2 types you can use. So it's very simple. This is less than 10 lines of actual code. So it's just defining your list of what's allowed, pulling all your EC2 instances from the plan, basically doing a filter to make sure all those things match in terms of the instance type, and then checking if there are any violations. If that returns false, then you're good to go. This is an example of CFLint, which is a tool that AWS actually released. This is actually more of it was released as a code quality tool for CloudFormation, but I worked on projects where they've used this to basically do security linting for CloudFormation. And then some folks are probably familiar with SemGrep, which is a semi-open source commercial product that you write these rules for any language, pretty much. And they have a Terraform rule set that's out there. But again, very customizable. And these are very straightforward to write, and again, pretty simple all in all. It doesn't take a huge amount of code to write these things. So the point is, these aren't massive code projects that take months to get going. You can write these pretty quickly. So one of the things that I've kind of learned from working on these projects is when you go to scale this, and eventually if you're a big enough company, you're going to want to scale this. So how do you scale out an IAC project that works for your large enterprise? So I think a lot of security projects kind of end up, or they start as skunkworks, and they kind of don't always mature into a full-on project. Whereas I think if you want to do this, I would start from a very security engineering mindset, as in build a security engineering team. You treat it like a development project, and by that I mean you use GitHub or whatever source using. You have all the best practices that you expect your developers to use. So Git flow, peer reviews, pull requests, all those types of things. Then I think one thing that I think some security folks who don't come from a development background don't think about, they're not used to being in the position of pushing things to production and actually having the responsibility to make sure things work. So when you write ISE code to run against people's production deployments, your production is their production and vice versa. So if you don't write good code, if it doesn't work as expected, you're going to break their production. And along with that is testing. You have to make sure that these are well-tested rules. And one thing we found is simulating actual real life scenarios is much harder than just what you think or how you think people are going to deploy things. And that also requires having kind of patterns of how people are going to adopt this and then subject matter expertise in those areas. Another kind of philosophical thing is, are you going to give developers kind of a playground where there's loose guardrails and you're just kind of enforcing the worst of the worst, or are you going to make paved paths where there are very strict kind of rules about how they adopt IAC? So that's kind of two different philosophies. So what can go wrong with these? I think the big thing is security doesn't always have all the context for how people actually use the cloud. So you need to make sure that you're living in the same world as your users. So that means writing rules that actually fit to the models and patterns that people are going to adopt when using cloud infrastructure. You have to be able to kind of root cause and fix things very quickly, because if you're breaking a production deployment, you are on the hook to fix that as soon as possible so people can get to production. It's also very easy for these projects to kind of scope creep. And that means kind of applying these kind of rules onto other facets of your infrastructure security that might not apply. It's like patching or scanning or kind of things like that. You might try to use them for too many different applications. And sometimes that can be useful and it's a very powerful tool. But also if you start trying to do everything in one tool set, you're probably just going to fail at it overall. And again, if you don't have a unified deployment model for how people will get stuff out to the cloud, you can write 1,000 checks, but if no one's actually using your pipeline and are forced to go through this, then it doesn't matter. And then lack of integration with runtime. So Terraform and CloudFormation, they do this kind of pre-deployment check to make sure like what is reality and what is about to be deployed. But that's only kind of what you're talking to and what you're modifying. It doesn't always apply for all the other kind of resources out there that are running your runtime. So some of those kind of dependencies or relationships, you might not have the insight into with these kind of tools because they're only running against the code. So to kind of summarize Homer's homeowners, so they're a large enterprise. They've been doing cloud for a long time, struggling to deal with this complexity over time. And they're trying to move to this model, and they've done a lot of work to move to this model where they're fixing things. They're not allowing things to go out the door broken, so they don't have to go behind it and fix them afterwards. And they can also scale up this program to meet kind of the next 100, 300 AWS accounts, thousands of applications that are coming out from their development teams. I'll hand it over to Ken.
All right, so Lisa's Lending. Think of Lisa's Lending as like your 200 to 700 person company that's got like a really great finance industry product. They're filling some like sort of niche in the market, and they're super successful in doing that. They've got DevOps and these processes that are mature and working, and they're really hitting the ground running. So if you had attended any of the previous talks, you would have realized that we identified three major problems in these sort of organizations. The complexity of those organizations, so what tools they're using, what tech stacks they have, and then not only that, but the complexity of all of the integrations that they use, because when these organizations spin up, a lot of what they do is outsource some of the functions that they don't want to spend time developing. So that can be your identity, your payments, your funding sources, maybe some underwriting, or like your LexisNexis of the world, Equifax, things like that. And so having to manage all of those is sort of like a supply chain issue. The other thing is regulation is constantly coming into these organizations as well. Most common ones you'll think of is like PCI, SOC, SOC 2. But some of these organizations don't handle credit cards, or they outsource it, so they don't actually lean on PCI. So that's something to consider. And then a unique issue is if they are trying to partner with something that's like a bigger bank or like a larger financial institution, a lot of times those financial institutions have to meet some sort of criteria for their auditors and are asking the folks that they are integrating with to meet the requirements of that without actually filling the audit before that larger institution is actually doing it themselves, so that they don't have to worry about it in the future. And the last piece is legacy hardware and software, and that was how do we solve for integrating, things like React and Node.js apps with a mainframe, like really unique scenarios like that, and how we can pass through and filter data, and what does that security look like in that cloud infrastructure and architecture when we're migrating a business like this to the cloud. So we did work through all of that, and we'll explain as quickly as we can how we got there. But one of the things that sort of popped up after we've gotten through all that and sort of felt like we were in a good, secure place was just comfort with the cloud. So we went from having these organizations that were like really uncomfortable with the cloud and working on migrating on-prem to cloud and reaching this sort of, I won't say lazy, but just like, what do we do next kind of thing. I also want to talk about this image because this image comes up all the time and it frustrates me to no end. And even 2 weeks ago, this came up in this same context. And I think that it's because this is marketed to business owners to like, what's your responsibility inside of cloud security? And I'm constantly coming up against this and they're like, oh, it's software as a service. We don't have to worry about any security. Like Salesforce will take care of it or whatever your SaaS provider is going to take care of it. But you do have responsibilities for the configuration of those tools in each of these sections that is really important for you to consider. So if you're using a platform as a service like EKS, you're still responsible for understanding and configuring EKS at the network storage layer. And AWS will provide you with a best practice on how to do that, but you're still responsible for that security. And I think that this sort of like transforms the shared responsibility model in a way that's not great. So as you're looking at this, and if you want to talk more about that, just be aware that this does not relate to like your security responsibility in an organization. So the way that we solve the problem in the initial set of complex issues was through this approach of enabling and enhancing application and development and operations teams. So we have a tendency in the security to think of how do I solve the security problem? And so and adoption becomes our biggest enemy of whatever we're trying to implement. And so every time we implemented something inside of these organizations, one of the things we asked ourselves is how can we have some enhancement to time, money, or effort for development teams or operations teams? The two major initiatives that worked or like proved this concept was key and secret management and stability. I'll just focus on one just in the interest of time. But in the key and secret management, like one of the big wins that we had was we were thinking about we need to change our strategy for how we manage keys and secrets because we know there's an issue there. The compliance organization was saying you need to have this expiration date, this rotation mechanism, this length of characters in your secrets, or this type of key management. And we were like, well, how can we use that compliance goal to set a bar that's going to actually change the game for our developers and our engineers to make sure that we are actually enabling them rather than just adding another security control. The way that we did that was through HashiCorp Vault. So we used to have this large process where we would manually rotate secrets, like 30 or 40 people between database admins, DevOps engineers, the actual security engineers that are working on there, and the admins of the development teams that are doing this because they're configuring it in their apps. We rolled out HashiCorp Vault. We had a goal of aggressive rotation times, aggressive expiration times. We were enabling things like every time you reboot the application, it would rotate the secret. We had a break glass procedure. So all these things were adding security mechanisms. But at the end of the day, we were also trying to be considerate of when an application team needs to access their app, how do they get that secret? And if they do have to require that secret for maintenance or whatever, how do we rotate it immediately? So it was all configured to rotate on reboot. So it was trying to take that approach of enabling them while we're adding the security control and meeting that compliance requirement. So this is just a sort of an aside of where we're going with this. So regulated financial services, with all this complexity, legacy requirements, and all that kind of thing can be a cloud hell, just like Ned Flanders here going into his own personal hell. But if you spend enough time doing it and you set the bar, you can you can become your own worst enemy. So we've moved from this like sort of understanding in these organizations from having this like complete cloud confusion to now we're confident in the cloud. Everybody's confident knowing what the security requirements are. We're hitting our compliance goals every single day, or every time an audit comes up, we know exactly what we're doing. It's becoming easier and easier. And we've gotten into this sort of rhythm of having this cloud confidence. But then we get sort of overconfident and we're like, okay, everybody, we can do this on our own. We know what security wants and what security is doing. And so you start to get a bit of shadow IT inside the cloud because people become more and more confident with it. And we were realizing we had no bar or measurement outside of compliance to say, even though we were trying to do more than compliance and make sure that we were doing more than checking the box, once we hit that goal, we had no difference, no delta in the measuring stick, and so we couldn't actually move it forward with anything to show them. So obviously that resulted in some issues in the cloud, and so your security goat needs to come and help them So what were our failures? The biggest thing was we were focusing on, we knew we didn't want to do checkbox security because nobody wants to do that, but we focused on compliance as our measuring tool, even though we were going above and beyond. And that causes like inward focus of we still hit the target and we didn't know where to go from there. So we had lacks of gap in measurement that we couldn't really use to facilitate selling that inward to management, things of that nature. So we needed to change that, and the criteria we came up with was we don't want to drive it with money because that means that we're going to have to buy something new, and that goes against that sort of time mechanism. We don't want it to be driven by compliance because that was our failure. We needed something that was going to create something actionable for us to do. We wanted to keep that sort of enabling mindset of making sure that we're focusing on team successes. And we wanted to focus on maturity of the organization over time rather than like hitting some metric that we set out at the beginning of it. And that we also needed something that was going to be flexible in what goals we could set. We wanted to make sure that just because whatever we decide to use says one thing, we may or may not agree with it. And we wanted to be able to self-assess. We didn't want to have to hire an auditor to come and tell us what was going on. So we evaluated a couple of different things, OWASP SAM, IANS, and the DevSecOps maturity model, the IANS Cloud Security Maturity Model, and OWASP SAM. We started to go with OWASP SAM, and if you want to talk about sort of why we didn't decide for something else, we can talk about that after. But the OWASP SAM provides this sort of really interesting viewpoint. I know it's not cloud specific, but the reason we really liked it is because it separates things into business functions and doesn't have this like goal that you have to hit, like maturity level 1 or maturity level 2. You could sort of pick and choose what business functions matter to you in that moment, and it allowed you to have this objective measurement. You could self-assess, you can provide these things to teams, or you can have somebody help that with, somebody more familiar with security to help you with that process. So we really like that. It allowed us to get that measuring stick, try to show progress to the organization and get everyone back on the same page and out of like some compliance metric while still meeting those compliance goals. And that turns us right back over to Bart's vetting. It's like 20 people, 20, 30 people.
Yeah, this kind of represents the opposite of Homer's homeowner. So during kind of our time working with different companies, we worked these smaller companies that I think are representative of startups or just kind of 100-person companies that they have a decent number of developers, but they don't have a dedicated security team. They're all cloud. They were never on-prem, relatively new development, but still regulated and still a lot of sensitive customer data. This could be a fintech or education tech or a lot of different kind of companies that are in this spot. So they're all adopting cloud, and they don't really know where to start with their cloud security. So some of the common issues we see, not technical issues, but their security is really driven by audits. What do they have to do every year in order to make their customers happy or the regulator happy? Lack of security tooling and staff. So they don't put a budget towards either one of these things besides kind of a quarterly or annual audit. And just short timelines as well. Any startup or small business is usually pretty timeline and financially driven versus kind of we want to make sure our security is really strong. So what do we see kind of on the security side with a lot of these companies? It comes down to the basics. So I was looking at some of the work that we've done, some of the reports, and it came down to kind of basic things. So amazingly, logging, despite it being very easy in the cloud, is one big issue that we see. I like to ask, if you can't tell me who did something in your cloud more than 90 days ago, then you're not doing a good job of logging. And these days, enabling CloudTrail takes 30 seconds, and it doesn't cost you that much money just to put the logs into S3. And so there's not many great excuses to not have these kind of logs enabled, but it's a pretty common issue that we see. Another one is encryption. So cloud encryption is more of a checkbox than anything else, unless you really don't trust AWS with your data, which there's a million other ways they can access it if you didn't, even if you're encrypted. But we see a lot of unencrypted data on RDS, on S3, EBS, all these types of things. And again, in the cloud, these kind of things are very easy to address. It's as simple as a checkbox, so you don't have to go through some very complex way to actually get this data encrypted. They can do all the key management for you. It's all very straightforward. And then lastly, kind kind of identity and user management. A lot of companies I've worked with, they don't have a strong user management kind of program, and that spills over into the cloud where they might not know who has access to what, and they don't do a good job of managing their users. And for some of them that do have spent some time building out, at least buying a security tool, a lot of these folks buy a tool, they get it hooked up to their cloud, and it's sitting there, it's harvesting data, it's throwing up alerts, but it's kind of like a lighthouse that no one looks at because there might be 1,000 alerts, but if no one's going in to look at them and going to fix the issues, they might as well not spend the money on that tool. Another issue I see quite a bit is data sprawl, where they'll have a decent amount of sensitive data, which should probably just live in like, an RDS instance or something like that. But they, for whatever reason, maybe it's data scientists or just another project that needs access to that data, so they copy it to, say, an S3, or they copy it to an EBS volume, and just over time that data just kind of goes everywhere, and they don't have a data management program that says, okay, where are all the places that we have data, how do we make sure that it's only accessed by the people who should have access, and how do we alert on those unapproved accesses. So that's something you see at large companies, but usually large companies have data custodians and programs around that. So small companies don't have that, but they have the same issue with their data kind of going everywhere. And multi-cloud, that's definitely a hot topic in the cloud world in terms of large companies trying to go to multi-cloud. Some people feel like it's a way to avoid vendor lock-in. Some people are just looking for a cheaper service potentially. What I'm seeing with smaller companies is usually they start with one cloud, so they'll have most of their applications on EC2 and AWS, but they actually will pick a couple Azure services that they like for some specific application. And that's all well and good. Different clouds offer different kind of strengths, but what you then have is you have multiple clouds, you have data in multiple places. You don't have a way to alert on those different clouds. You don't have a security tool for those different clouds. You're managing identity in those two different clouds, network, and so it's just the more platforms you adopt, the more your kind of responsibility to secure these, and people don't always have the skill set or the budget or the tools to do that. So what should you do? Really start with the basics. If you're a small company that is using the cloud, really just adopt the basics. So what does that mean? Having logging for all your services set up. That's again very straightforward and simple, and if you ever have some kind of incident or breach, that's going to pay dividends for a long time. Identity federation. So figure out how you're going to manage your identity. There's a lot of different options these days, even on the cheaper end. So you can use something like G Suite, you can use Okta, you can even use Azure AD, and then federate that into AWS. And have alerting. I mean, even the basic budget alerting is really helpful for small companies if they don't have an official security tool to do that. And then try to figure out kind of a unified deployment process for how you get things into the cloud and standardize on that so everyone is using kind of the same method.
All right. So now we're at the smallest organization in the series of 4, Maggie's Mint. And this representative, we'll call it, 5 to 10 different blockchain organizations I've had the really fortunate opportunity to work with over the probably last year and a half or so. And we added this to the finance thing because, I don't know if you saw the blockchain talk yesterday. But it was sort of, it can be eye-opening if you've never looked at this stuff before. And in a cloud security talk, there's a footprint here that I'd really like to sort of address. So a typical sort of organization that we're looking at here is we'll call Maggie's Mint. Maggie's starting her new token, her doggy coin here about Santa's little helper, and she's ready to get this going. It's one developer / engineer working on this project. She wants to have not only something on the blockchain, but she wants to be able to have this community that is like interactive. People can transfer tokens and do all kinds of things with each other, maybe fund their wallets from banks and things like that. So a typical organization like this is a small team, probably like 1 to 3 people to start out with. And we've seen, a variety of different sizes here, but this is there are some that are just like maybe 1 or 2 teams, 1 or 2 people, or a really tiny team, maybe like of 3 or 4 blockchain developers. There's also this sort of lack of cloud knowledge and support. So when they are doing anything, establish any infrastructure in the cloud, they're sort of doing it how they know. They're not really trained in cloud security or cloud knowledge, and they are doing the best that they can with that. Sort of going back to that knowledge gap that Mike had talked about between security and cloud, same kind of thing. There's also this like really weird extreme trust in the blockchain that as long as I put it on the blockchain, it's cryptographically secure. So I'll just focus on those things and nothing else. And there's also this sort of, in that same vein, this idea that the client side, the JavaScript application in Web3 that connects to the blockchain, we don't have to worry about that because as long as the blockchain is secure, I'm secure. So there's like sort of that mentality as well. The other 2 interesting things is, one, just open source contributions to these projects. Some of these projects get, their development team is literally like Moe's Bar, right? It's just everybody that wants to contribute to the product. They're chatting, they're solving each other's problems, and it's a really great community. But at the same time, there's a security risk that we all know goes into open source projects as it is. And now you're talking about a finance project that is public, that is allowing people to submit code and all the problems that come along with that. So think of your supply chain attacks and things of that nature, but with a finance institution. The last thing is sometimes a lack of a dedicated security team. We see a lot of these organizations focusing on bug bounty programs, but they don't have necessarily a dedicated security team, or their security team isn't like cloud security or infrastructure security. They're more like application security engineers that focus on a very specific nuanced security inside of smart contracts or blockchain. So that's where we're starting. And there's also this sort of leadership persona that I've sort of started to notice. There's like 3 sort of, I would say, like folks that you'd sort of talk to if we had to put them into buckets. One is like, I'm doing this smart contract. I don't really, everything that the user does, if they connect their wallet to my system, it's their problem. If they mismanage their funds or whatever it is, like I don't really care. I'm just going to provide it. I'm going to make sure my smart contract is secure, and everything else is on them. The other like sort of middle ground is folks that want to protect their users or want to protect their user base and their brand, but don't necessarily have the knowledge in cloud or maybe the resources to do so. And the last are like people that are evangelical about protecting their user base, their market, their brand, making sure that they're changing, they're doing this for the future, and they really want to know all these things, but maybe they don't have the budget or the knowledge to know what they don't know. So really the way that we can kind of play as traditional security engineers or cloud security engineers is sort of on the right side of this in the I don't know or protect them all phase. So what's a common cloud security architecture for a blockchain organization look like at this size? This is really simplified from what we've seen, but typically you have something like Maggie, Snowball, and Santa's Little Helper starting their blockchain organization. They're deployed on Kubernetes, maybe they're in EKS for the UI or something, but they maybe haven't gone through the best practice in AWS kind of guide. They have RDS, but that RDS instance is storing things like user keys or private information, and they've maybe enabled encryption, maybe they haven't, but they're not necessarily aware. Like the parameter store or secrets manager or HashiCorp Vault, like we talked about before. And so they're trying their best to use what they know to fulfill the need that they have. I've seen things like EBS for file uploads, like people make NFTs and stuff, but they're not encrypted because they're in the back end. So there's this assumed trust behind the wall, behind the load balancer. We've seen the same thing at public S3 buckets, all the common problems we go through, but for things that they don't assets, all those open source contributions we talked about, and then again, no security team. So I think what I want to sort of drive home here is that it's really easy to point the finger and be like, they don't know what they're doing, or cloud security is things that they're failing at. But just like there's a gap in cloud security and application security, I think that like they're going to know things that you don't know, and we're going to know things that they don't know, and we sort of need to like cross the aisle a little bit here. Help them understand, where their security footprint and their attack surface actually is, and that it goes beyond the blockchain. So how do we do that? For me, in the last year and a half, I found some real success with threat models, and really just starting with a basic threat model. If you can get a blockchain organization in the room, or if you are working with an organization that is looking at blockchain, start with the basics of a threat model. Ask what goes into the entire ecosystem of what you're developing. Stride is okay. I've had people ask me what is Stride and why does it matter for blockchain? I thought that was something for applications. And you're like, but you are an application. So, or you Stride for anything. So it's like trying to describe what it is and how it fits their world is a really important thing. Draw a diagram, get drawing. A lot of these organizations have really good white papers, really good research, really good cryptographic analysis, really good but they don't necessarily have an architecture diagram that tells you what is the holistic view of their entire ecosystem and what's their infrastructure architecture look like. If you draw that for them, you're providing them with 1, a threat model, and 2, a diagram that they haven't taken the time to write or do. It also helps you create an inventory that you can continue to walk through threats with and then build on that. And just assume nothing. Even if you just take a best practice guide to that conversation, I think you'll find something. So how do you join the crypto party? And if your company is in crypto or you're involved in that conversation somehow, again, document and draw things, review client applications. Don't just assume the JavaScript is going to be completely safe. There is an attack surface there. A threat model at not only the blockchain level but at the component and infrastructure level. Identify and know the trust boundaries of where your application is and review the security controls that are there. And talk to security people. Just pick security people's brains because they spend all their time trying to think about how to break things and defend things, and let them loose on that sort of organization. And that wraps up the Maggie's Mint. So I guess the next question is, what can I do today? So all of these, like we said, have very, very common themes across finance. And so I think that we can sort of break this down into 4 areas. The first is focus on enabling teams over just attaching security. Make sure that what you're doing is changing the status quo of not only the security in your teams, but also what they can do on a day-to-day basis. How do you make their job easier? How do you enable them faster and enhance the speed? The other thing is measurement. I think that we're always sort of having these really crappy KPIs in security, like the number of vulnerabilities or all these kinds of things. So it's find a measurement that works that will allow you to establish trend lines in your organization for your security and measure, like we were talking about with the OWASP, Sam, a delta between what you're doing, set a goal, get there, set your next goal, be able to actually show improvement over time. And I think that over time is the key there. And Mike, you can talk about the other 2.
Yeah, the other 2 are kind of deep wins, which we mean by that. Ken coined that over whiskey, so blame him for not understanding it. But where can you solve an issue that you solve at one place and it kind of has a domino effect across multiple areas? So that's what we saw with homeowners, with kind of addressing security at the root of where infrastructure and cloud resources are deployed, and that kind of gives you benefits in a lot of different areas. And then for smaller companies or just kind of less mature places, just cover your basics. A lot of people, we focus on 0 days, we focus on crazy attacks, but really the basics are still not covered in a lot of places. So make sure that those are covered first. And so what have we learned? I think what Ken and I have learned from kind of our experience doing this is cloud security is hard to scale, small or large or medium size. It's just a hard challenge. So you have to plan early and adapt often. So have a plan and then be ready to adapt that as new services or new strategies or just new patterns are adopted. And then just be comfortable with complexity and acknowledge your risk trade-offs. Anything else you want to add?
No, but if you do bring down production, then you'll be in Bart's shoes here. Basically just, kind of see the common themes across finance in no matter what technology stack you're looking at. If you want to get a hold of us, we have a little thank you slide here. I'm at Kadelsky Security. You can reach me on Twitter as well here. If you're interested in listening to my podcast, the link is there as well.
Yep, and you can reach me on Twitter or my website. Thanks.